Right. So hydropower plant, is there anyone having any doubts about the process of flow of hydropower plant, how it is converting any components, equipments, the importance of penstock, surge tank, spillway, or is the process of hydropower plant? Hope everything was clear how the electricity is getting generated in hydropower plant. I need quick responses so that I can proceed. And the students who are responding, that only I can provide the attendance. So each one has to respond at any point of time before closing of the session. So based upon that, parallelly I can note down the roll numbers. So login and keeping mobile aside is not acceptable. Very short duration, you have to be focused a little bit so that you can understood how the process is going on, the generation of the electricity by different methodologies. The first one we are completed yesterday, the hydropower plant. So already answers are highlighted. And can anyone answer this? Just to revise yesterday's topic quickly. What is the primary purpose of penstock in hydroelectric power station?
To transport water to the turbine.
Yes, right. Nishant, only one answer from you so that I can keep the attendance. Okay. So don't respond again. I will ask. For the remaining students has to respond immediately. What is the primary energy conversion process in a hydroelectric power station?
Sir,
Potential.
potential to kinetic to
Potential.
mechanical to electrical.
Potential to connect.
31, 15, and 24. Right. And the last one, what is the function of surge tank in hydroelectric plant?
To absorb pressure
The
To
pre-
fluctuations.
observe pressure
To observe
fluctuation.
pressure.
Pressure
To observe
fluctuation.
pressure.
Right, done.
Pressure,
Done. I
To
Pressure.
observe
understood.
pressure function.
No repetitions. I noted down the roll numbers also. Pavani, Nidanash, Deepika. Right. So today we will quickly move on to the thermal power plant or the steam power plant. Someone still in waiting room. Is the screen visible, ma? The thermal power plant? The schematic diagram?
Yes, sir.
Right.
Yes, sir.
Right. Good.
Yes, sir.
So just I will go through the process, how it should be starting and how it is ending with the generation of the electricity. So where the process is going to start, it should be going to start with the coal storage. So generally coal, where we will get the coal, from where we can transport, coal is transporting from where?
Mines.
Right,
Mines.
right, very good.
Mine.
From mines, we are transporting the coal to our nearby thermal or steam power station. All right. What is the basic principle? Yesterday, we just gone through the basic principle of the thermal power plant.
Uses heat energy or
Heat
Correct.
steam.
energy to convert electrical energy.
Very good. So the basic principle was that the generating station which converts heat energy, it should be through coal combustion into the electrical energy. That is what we are having the basic single line of steam power station or thermal station. But here the advantage of steam thermal power station was these also we are discussed in yesterday. What are the major advantages? The fuel was very cheap. Initial cost was less, whereas for hydro the initial cost was very much high. But it is an advantage for thermal power station that initial costs are less compared to any other generating station. Remember, not only with hydro, because yesterday we are completed hydro, so that I compared with the hydro. But in general, it is compared to any other kind of a generating stations like diesel or gas or it should be nuclear, hydro, whatever the kind of a generating station, this thermal station has a low initial cost, remember it. And the cost of generation by default, it should be lesser. But there is also a drawbacks, the major drawbacks from the thermal station. The major drawback was pollution. So why the pollution is going to happening? It will pollute the atmosphere due to what is the reason? Main production of the large amount of the smoke. This is the major drawback which will creates the pollution from outcome of a thermal power station, major drawback. And there is another drawback was that already we discussed yesterday, the running cost will be a little bit of costlier compared to the hydroelectric power plant. Whereas hydroelectric power plant, the running cost in the sense the operational cost. Once it should be getting started everything, what is the maintenance cost? All these are falls under the operating cost or running cost. So these running cost will be less for the hydroelectric plant, and whereas for thermal it should be higher. Right. Coming to our schematic layout diagram, how the process is going to start. What I said earlier, that is from the coal. Generally, the coal is transported to our power station by the medium of either road or rail. Maybe you can visualize many times some goods rails which are carrying some coal, right? So these coals is a primarily a matter of protection against general ఎలా ఉంటుంది మనకి coal అనేది. Where is the drawback? Singareni we are having nearby. What is the problem in Singareni? The coal mines. When we will get issues to get the coal during
Like what, sir?
strikes. During strikes time, we are unable to retrieve it, right? So this is one of the area where there is a maximum possibility of lag, or we can mention that as a failure of transportation system sometimes. In general, very rare case, the shortages of the coal in the mines. So generally, the availability of the raw coal should be affected due to these kind of strikes, or there is certain transportation issues, or maybe the shortages in the coal mines, right? So the main raw material required in order to generate the electricity in thermal power station is coal. So the first where we have to be concentrate on the getting the coal to our steam power station or thermal power station. Right. From the core storage plant, generally coal should be going to deliver to what is the next block you are seeing after cold storage?
Handling plant. Handling plant.
Right. Coal handling plant. So what coal handling plant will do? Already the coal which is transported from the coal mines is getting stored in the first block, that is coal storage. After storing, this coal will be transferred to coal handling plant. In this coal handling plant, the coal is getting pulverized. Pulverized means we can crush that into a very, very small pieces in order to increase its surface exposure. So the coal handling plant is where it should be giving the small amount of pieces of a coal which is required for the boiler to boil. Okay, this is the work done by the coal handling plant. Understood the first two blocks, the coal storage and the coal handling plant. Okay, then what next? This pulverized coal, where it should be going? This small pieces of the coal is fed to what is the next box?
Boiler.
Boiler, right. There is certain belt conveyors will be there. Through these belt conveyors, we can send this pulverized coal to the boiler. Okay, so the coal is then burnt in the boiler. Once coal should be getting burnt in, what is the purpose of boiler? To boil whatever the content you are provided, right, with high temperatures. So once the boiler starts its operation with the input of this pulverized coal coming through conveyor belt, after burning with higher temperatures inside the boiler, this coal is giving certain amount of ash, right, along with the heat. So the coal is burnt in the boiler, and what is the byproduct is produced ash. So this produced ash after complete combustion of the coal is we need to be removed. How we can remove? see that there is an arrow mark which is going down to another block below the coal handling plant. What is that block?
Ash handling.
Ash handling plant. Very good. So the pulverized coal sent to boiler. After boiling, there is a byproduct of this ash. That ash should be coming out through the ash handling plant, and then it should be removed through the ash storage, and it should be moved on outside. Understood up to these 5 blocks? So this is a proper burning of a coal. The removal of the ash from the boiler furnace, that should be mandatory for us for proper burning of a coal. Right. Generally, how much percentage of this ash will be produced means it should be depends on the kind of a coal, the quality, and at the same time, the percentage of this ash will be again depends upon the temperatures we are using in boiler, how much amount of coal is getting fired. So if you consider, let us take an example of some 100 or 200 megawatts of thermal power station operating at certain load factor. That means some 50% or 60% of the load factor. Then typically it will take around 20,000 or 25,000 tons of a coal. For 30 days, I am talking for a month. So the ash produced may be some 10 to 15%, not 50, 15% of whatever the coal you are getting burnt. That means, for example, there is a 25,000 tons of the coal per month you are using to burn for the combustion purpose in the boiler. Then how much amount of the ash will be getting produced? It should be around 10 to 15%. Let us take if it is a 10%, it is a 20,000 tons. Then by default, how much tons of the ash will be getting produced in the ash handling plant? Around 2,000 tons of, 2,000 tons or maybe 2,500 tons of the ash will be getting produced. Understood? That is the reason the thermal station around 50 to 60% of the total operating cost will be consists of this coal purchasing and its handling process. The rest of the process is generalized process. The main running cost or maintenance cost, or we can also call it as operating cost, that should be purely around 60% of this running cost will be burdened on this thermal station due to this coal, taking the coal and handling it and ash. So this is the one of the major area you need to be identified for the competitive exams. The 50 to 60% of the running cost will be bared by this coal handling plant and ash handling plant. Right. Done. What is the next process? The boiler. What generally the boiler will do? The heat of combustion of the coal in the boiler is generally where we can utilize to convert. See, there is certain heat from the water, right? That means water is now converting into steam at high temperatures. Understood? Water is now converting into steam because you are giving certain high temperatures and pressure inside the boiler. Then along with that steam, what you will get, some flue gases you will get. That means some high temperature, what I can mention, the flue gases. Can anyone have an idea about the flue gases?
No idea, sir.
So these are nothing but some byproducts happening during the combustion of the coal at high temperatures. Generally, these gases will be released in our regular scenario also. There is something burned. There is some gases which are going to affect even our health also if you are nearer to that combustion. So generally these flue gases are either carbon dioxide or something related to nitrogen. These are the mixture of all these components. We cannot restrict to exactly this is the flue gas is going to generated from this combustion. So it should be purely depending upon the material you are using for the combustion. So all these what I can call a mixture of these gases, nitrogen, carbon dioxide or oxygen sometimes. So there are certain pollutants. We can, the mixtures, we can call it as a nitrogen oxide, carbon monoxide. All these are called as flue gases which are coming during the something combustion is happening in our particular area, whatever you are doing. Similarly, in this boiler also, there are along with the steam, there is some flue gases are going to present. Remember, these flue gases are not good for the atmosphere. Okay, these are generally treated to remove the pollutants before we are releasing into the atmosphere. This is very much important by using certain filters kind in industries, regular industries. All right. So the boiler completed its task like heating, and after coal, what should be going to happening? See, boiler, there is a river. Are you able to see the bottom of the schematic diagram?
Yes, sir.
Right.
Yes, sir.
So
Yes, sir.
from the river, the water treatment chamber, and the water is going towards the where it is going towards the economizer. So from economizer, what it will do? Economizer will able to do the using the flue gases. This economizer is going to heat the water which is circulated through the economizer. That water again sending to boiler. And this water and whatever the steam which is already generated from the combustion of the coal, combination is sent to superheater. This superheater further increase the temperatures inside of that superheater and making the wet steam into dry steam. And that dry steam again, they're having certain flue gases. That flue gases again uses in the economizer and followed by the air preheater. What air preheater will do? It will increase the temperature of the air, which is supplied from the coal burning by whatever the deriving heat from the flue gases. So that is the purpose of a air preheater, which is going to extract the heat from flue gases and increase the temperature of the air used for coal combustion. See that air preheater, the input is again sending back to the boiler. That is the hot air which is extracted from the flue gases coming from economizer. Understand the process, ma? So this is all the process generally where it is leads to the main objective was that to rotate the turbine. How the turbine is going to rotate now? The dry and superheated steam from the superheater. See, after boiler, there is a superheater. The output of superheater is given to certain valve. By using this valve, this alternator, sorry, this turbine is going to connected. What the turbine input? The dry and superheated steam from the superheater is fed to the steam turbine through main valve. So the superheated steam from the superheater is the input for your turbine in order to rotate its blades. So the heat energy of the steam when passing over the blades of a turbine is converted into mechanical energy, or we can call it as a rotating, simply mechanical energy. That means the thermal energy converted into mechanical energy. Remember the conversions of the energy here. Thermal energy is produced. After that, thermal energy is converted into mechanical energy as an output of your steam turbine. Now, the output of steam turbine is coupled to which component?
Alternator.
Very good, alternator. So the steam turbine is always coupled to alternator in a thermal power station. So this alternator, what it will do, already we seen in hydropower plant. It will going to convert some mechanical energy of that particular turbine into electrical energy. Simply the generator, what I said in yesterday's session, generator. So this generator, or we can also call it as alternator, where we are converting this mechanical energy output of turbine, that is the input of our alternator converted into electrical energy. Done. Now the output of alternator, we got electrical energy. It is derived to the, oh, the meeting is going 10 minutes. All right, quickly we can complete the process. So the output of alternator is electrical energy, which is delivered to our bus bars through the transformers, circuit breakers, and isolators. The way you are seeing the isolators, circuit breakers. CB means a circuit breaker, and it will be connected to your bus bars. Right, understood. Now there is a question, maybe you may have some doubt. What is the purpose of this feed water, river, this arrangement? The upward arrangement was clear, everyone?
Yes, sir.
That means from
Yes, sir.
coal to handling plant, boiler, and the ash will be collected to ash handling plant, and the boiler output is connected to superheater. Superheater output is connected to turbine through the valve, so that steam should be going to strike the turbine blades, and the turbine blades will be generating mechanical energy from the thermal or heat energy as an input for the turbine. And this mechanical energy of the output of turbine is coupled with alternator, then that will be fed as an input to the alternator, and this input mechanical energy is converted into electrical energy, and it will be delivered through the isolators and circuit breakers to the bus bars. This is the process is happening. Done, understood. So here the superheater, what I mentioned, there is some flue gases which are presented. Here the purpose of feed water and a river was that very simple, the condensate, that what I can mention as a condenser we are using in feed water. See, there is, you can zoom it here. Unable to zoom it. You can see there is a condenser. Are you able to visualize above the cooling tower?
Yes, sir.
All right. So,
Sir.
where is the input of that condenser? For the condenser, the input coming from
So coming from
Circulating
cooling,
water pump.
water.
circulating water pump.
Water, right, right. So the feed water, what it is doing on its way to the boiler is heated by the water heaters and economizer. Why we are doing this? In order to improve the efficiency, overall efficiency of the plant. So in order to improve the overall efficiency of the plant, whatever the steam which is exhausted from the turbine, see the turbine output before coupling of the alternator, there is a line which is connected to condenser, right? So here
Exhaust steam.
yes, the steam which is exhausted from the turbine, that means the output of the turbine is somewhere connected to the condenser. So here the water is whatever you are getting the water generally from the natural source, what I mentioned here is a river or certain canals or lakes which are nearby, or you have to create that in your nearby thermal power station. So from these lakes, rivers or canals, whatever the source, that is a natural source bodies. So these water should be getting taken from these natural sources, and it should be getting circulated through the condenser. Why? The circulating water, what it will do? The circulating water is always takes up the heat of exhausted steam from the turbine, and itself by default it is becomes hot, right? So this hot water coming out of the condenser is discharged at a sustainable, or we can mention it as a suitable location down to the river. For example, the availability of the water from our source is not up to the mark because it is a continuous process, right? Throughout a year, if there is not sufficient water, the source of supply is not available, then what we have to do? There is an option of a cooling towers. Generally, you can see in all of the thermal power stations which are existed in our states also, these cooling towers we are going to use. So when the cooling towers are going to use? During the scarcity of the water in particular canal or lake, whatever the source of the water you are having, then these cooling towers will be coming into the picture where hot water from the condenser is passed on to the cooling towers where it is getting cooled. So that the cold water from the cooling tower is again reused, recycling in the condenser. Understood, ma? The process of the thermal power station?
Yes, sir.
Very simple process, just you need to be understood how the process is started and how the process is going to be ended. What are the major components in it? Anyone having any doubts? And Here, one more point we need to be remember for the examination point of view. There is a kind of a cycle we can mention, that is a Rankine cycle. Now, what we see in the process, just I will give a single line process of this thermal power station. Let us start with water, like from your tap or somewhere. Heat it up. Then what should going to happen? Still, Ritik is in waiting room. One moment. All right. Sai Venkat, post absenteeism once, so that I will cross verify.
Yes, sir.
Quick. Right. Let us take a small example of this thermal power station in our routine life. Take a amount of the water from your tap. That means a certain flow should be there, and make it heat with certain kind of a water heater or a boiler with some high pressure steam. It should be going to convert by default after particular heating of that water. Whatever the steam which is getting generated, let us feel generally what we are having at our home. Kettles you are having. What kettle will do? Just your
Heat.
yes, you are provided certain water inside of the kettle and switching on, so that the heat should be getting generated. So that by opening the kettle, you will get some steam. So this water boils and creates some powerful steam. All right. Now, whatever the steam is getting developed, now make it to apply as an input for the turbine. Okay, that means what, like a windmill you can consider. Windmill, everyone have the visualization, right? So consider a windmill. Now the force of this steam will make the turbine to spin rapidly. That is the purpose of this turbine. We are having some input to the steam. Then this turbine is starts rotating by getting a strike of this powerful steam on the blades of it. Then the rotation will give some kinetic energy, that what I can mention it as a mechanical energy, that is getting coupled with the alternator or generator in simply. So the generator, coupled generator, what it will do by default, it will be taking the mechanical energy from the turbine and converting that into the electrical energy. Right. Now, after passing through the turbine, the steam is getting cooled down in the condenser. Still there is certain heat is there, that steam evaporates and that should be getting cooled down in the condenser, that is turning back into your water. So this is like the cycle should be getting repeated. That means the water is then pumped back into the boiler and starting the cycle again. So this is a continuous loop where water is constantly being transformed into steam and back to the generation of the electricity. So this cycle loop, continuous loop, we can call it as a Rankine cycle. RANKINE. Very important for GATE kind of a objective multiple choice questions in competitive exams. Rankine cycle. This is a fundamental process that generally powers the electricity. Most of the generation plants, whatever we are using, that is nothing but your thermal power station. Right. Hope everyone was clear with the thermal or steam power plant, how it should be going to operate. This
Yes, sir.
above chimney,
Yes, sir.
see
Yes,
the
sir.
last point, the top of that, the induced draft fan and chimney. This is the area where you are getting sending the flue gases out. The least preferred and remaining, which are not at all useful, we are sending them out by using this chimney. I hope every components in this schematic diagram was cleared now, so that we can go for a small multiple choice questions on today's topic. Can anyone answer for first one? First one answer.
C.
Which type of power station converts heat energy from coal combustion?